The very last section. How are you guys feeling about that? You excited as I am? I know you are. All right, we're going to go about two means again, just like we did in 11.2. However, this time, and they are independent samples, which means they're two separate samples of data, right? In 11.2, they were dependent, so they kind of were the matched pairs and worked together. This time, it is independent samples, all right? Okay, so to test a hypothesis regarding two separate population means, 1 and 2, that's why you have the subscript on all of these, because they're showing two separate, okay? With unknown standard deviations, we can use the following steps. The samples are obtained using simple random sampling, 2 levels of treatment because they're two separate. The samples are independent. The populations are normally distributed or they're big, right? If they're not, that's when we do that extra test in order to make sure that they're good. Notice, because there are two independent samples, you have the first one, everything is denoted separately. You have the first one, so subscript 1 has to be greater than 30, and the second one. Everything is based on two separate samples. So to get the difference here between 11.2, which are the matched pairs, and 11.3, which are independent, this deals with two separate samples all the time. Each sample has to be less than 5% of the population, right? Exact same thing over and over again. It just has to happen for each sample at that point. All right? Okay. Everything is based on, I'm going to make this bigger, two separate means. Two-tailed still doesn't equal. Left tail is still left than. Right tail is still greater than. One thing that I am going to put on here that sometimes this is written as H naught is the first mean minus the second mean equals 0. Sometimes it's written like that. All right. So if you have these two pieces that you're looking at, and then everything else is the same, you just subtract it to the other side. So for this first one, it would be mean 1 minus mean 2 does not equal 0. Same thing for this one, right? Mean, I'm going to scoot this back. I got it too close. Here we've got 1 is mean 1 minus mean 2 is less than 0. Mean 1 minus mean 2 is greater than 0, right? All you're doing here in all of these instances, I'm just subtracting mean 2. So when you subtract mean 2, then that minus mu 2, then mu 2 minus mu 2 is going to be a 0 on this side. It's just always a 0 on that side when you subtract it over. So we're still talking about the differences, right? Because we have two separate samples. We're still looking at the differences here between these two. The biggest deal whenever you have that subtraction is I'm not just trying to find the difference. It is the relationship between the two. So we're looking at those. This difference here cannot be 0. Sometimes you're saying in that aspect. All right. Okay. Most of the time it looks like this. However, I do want you to see what this is. And of course, this is the same for all. I just didn't write it in there. But that way you can see what it is. Same deal. We're not doing anything with the classical approach. We are just going to keep using StatCrunch. Oh, surprise, surprise. P-value has the exact same scenario, and we'll state our conclusion. Now, I'm going to make this part bigger because we do have this test statistic. These are independent, separate, right? That's the whole concept here. I have, simmer down there, iPad. I have a sample mean 1 minus the sample mean 2. The population mean 1 minus the population mean 2. The standard deviation of 1 squared, that's what that means. So this is the standard deviation of number 2, and then this whole thing is squared is another way to write that. But you don't have to write The parentheses in there just because you understand it. This subscript 2 just means all of the ones go together, right? And then all of the twos go together. That's the whole concept. And then these are squared because it's an exponent rather than the subscript. Again, StatCrunch is our best friend when it comes to calculations. So we are going to have StatCrunch do the work for us, but I also think it's important to understand all the different aspects, and I want to drive in the concept that these are two separate pieces of data. So I have to have a sample, I have to have a population, I have to have a standard deviation, I have to have the sample size from each one. Here's the other thing that could happen. Now, the example we're going to do, they're going to be the same, but you could have different sample sizes because they're independent. They don't have to be the same. You're getting information from two separate pieces of data. Independent, right? Okay, so I'm just driving home that fact. I want to make sure that you get that out of this, and then we can go forward. All right, and then all the same stuff happens over here. The p-value less than alpha, still going to reject the null. Do I have enough evidence? Still going with that. Isn't it nice? You learn something and then we just keep applying it. So this isn't like brand new information. I'm just taking some set of data and then ultimately I'm doing the same thing with it. Pretty cool, really.